The Boeing 767 has 5 AC electrical power sources, 2 engine-driven generators, an APU-driven generator, a hydraulically driven generator, or HDG, and on the ground, an external AC power source. None of the generators can operate in parallel with one another. The Boeing 767 electrical power system is highly automated to reduce crew workload and improve system reliability. Although it incorporates all of the system functions and protections that were inherent to older aircraft electrical systems, the 767 system automatically isolates electrical faults. In addition, the electrical system automatically connects and disconnects APU and engine generator power as necessary. The principal AC electrical power sources are 2 engine-driven generators and an APU-driven generator. A non-time-limited hydraulic motor-driven generator, or HDG, serves as a backup AC and DC power source for extended-range twin-engine operations. The electrical system is controlled through the AC control panel and the battery standby power control panel located on the overhead panel. ICAS provides relevant messages to alert the flight crew of electrical non-normals. Two integrated drive generator units, IDGs, are installed. Each IDG contains a generator and constant speed drive unit in a combined housing. The IDGs can be disconnected from the engine by a momentary, guarded generator drive disconnect switch on the AC control panel. Disconnection of the IDG is irrevocable in flight. The IDGs can only be reset on the ground by maintenance. The action to disconnect an IDG is normally only taken in response to an illuminated drive light in the generator drive disconnect switch and an ICAS advisory message of left or right generator drive. The drive light indicates that the associated IDG's oil temperature is too high and or the oil pressure is too low. After performing the drive disconnect, the illumination of the generator control switch off light indicates that the IDG has disconnected. In this situation, the generator control switch remains in the on position with the on light displayed and the flow bar in view. However, the illumination of the off light in this switch indicates that the generator breaker has opened. Now we'll describe the generator control switch and IDG disconnect switch for normal operations. Before engine start, the generator control switch is normally in the on position with the on light, flow bar, and the off light in view. The off light indicates that the generator breaker is still open at this time. With the switch on, the generator breaker is armed to close when the generator is putting out proper power. The generator drive disconnect switch drive light and the generator control switch off light remain illuminated until the engine is started. The drive light extinguishes as the IDG oil pressure builds up, followed by the off light extinguishing as the engine reaches idle RPM. Click Start Left Engine and observe the left generator drive disconnect and left generator control lights. The engine-driven generator, in accordance with the AC bus power priority, automatically replaces external or APU electrical power connected to the associated AC bus. After the generator is online, if a fault is detected, generator fault protection will cause the generator switch off light to illuminate, and an ICAS advisory message of left or right generator off is displayed. If the APU is operating, its generator will automatically take over for the failed engine generator. If the APU is not operating when a generator fault is detected, the opposite generator will pick up the unpowered AC bus through the crosstie bus. Click Fail Left Generator and observe the operation of the left and right bus ties.
The APU generator is a third electrical power source. On the ground, it may be used in lieu of external electrical power. The APU is normally started before pushback and used to power the aircraft until the engines are started. On the ground and in flight, the APU generator may be used as a substitute for one or both engine-driven generators.
Electrical power from the APU flows through the APU generator breaker to the tie bus. The APU generator control switch normally remains in the on position. Regardless of APU operation, the APU generator off light will not normally illuminate when the switch is on. The APU generator off light indicates that the APU generator control switch is selected to off, or that a generator fault has isolated the APU generator with the APU running. Select the APU generator switch off now and see the effect on the electrical system. Selecting the switch to on, flow bar in view, causes the off light to disappear, APU operating or not. With the control switch on, the APU generator breaker operates automatically according to the priority system. Select the APU generator switch now and see the effect on the electrical system. APU electrical power distribution is through the tie bus. Provided external power is not connected to the tie bus and both engine-driven generators are not operating, APU generator electrical power is applied to both main AC buses through the bus tie breakers. Select the APU generator switch now and see the effect on the electrical system. As soon as an engine-driven generator comes online, the bus tie breaker of the side powered by that engine generator opens automatically to isolate that side from the APU generator to prevent paralleling of two power sources. The engine-driven generator powers the respective AC system, and the APU continues to power the other AC system. Click the Start Left Engine prompt now to see the effects on the bus tie switches. When the second engine is started, the bus tie breaker of the side powered by that engine generator opens automatically to isolate that side from the APU generator to prevent paralleling of two power sources. The APU generator has been automatically removed from both AC systems, however it remains as a backup power source in the event of a failure of an engine-driven generator. When the APU shuts down, the APU generator is no longer available. Click the Start Right Engine prompt now to see the effects on the bus tie switches.
Before we finish our APU generator discussion, let's discuss an APU generator fault indication. With the APU control switch in on and APU running, the off light in combination with an ICAS advisory message of APU generator off indicates an APU generator fault. An external power receptacle on the right side of the airplane, just aft of the nose gear, allows connection of an external electrical power source.
Although both APU and external power connect to the bus tie, only one can be on the bus tie at a time. Paralleling of power sources is not possible. An illuminated available light in the external power switch indicates the power source voltage and frequency are within limits. External power must be manually selected. Pushing the switch to on closes the external power contactor and also trips off the APU or the engine-driven generators. After the external power is online, starting the APU will not cause the APU generator to automatically replace external power supply to the aircraft. Select the external power switch now and see the effect on the electrical system. Conversely, with external power on the AC buses when the engines are started, the starting engine's generator automatically replaces external power on its AC bus. Click Start the left engine and start the right engine.
A hydraulically driven generator, or HDG, provides a fourth generator electrical power source, albeit a much smaller generator than the engine or APU generators. The HDG is a non-time limited generator capable of operating essential systems for ETOPS operation. The center hydraulic system supplies the hydraulic power to operate a hydraulic motor to drive the generator. The HDG is automatically activated whenever both AC buses lose electrical power in flight. The HDG powers 7 buses: the captain's flight instrument transfer bus, the left and right AC transfer buses, the AC and DC standby buses, the battery bus, and the hot battery bus. Notice that the first officer's flight instrument transfer bus is not included with the HDG. There is a short time delay between the actual power loss on the AC buses and the activation of the HDG. Also, because the HDG transformer rectifier DC voltage is usually lower than the voltage of a fully charged battery, the battery discharge light may illuminate when the HDG starts operating. This can occur until the battery voltage discharges down to the output voltage of the supplied HDG power. How do you know when the HDG is activated? You would see the indicators of a dual AC bus failure with the exception of the items that are powered by the HDG-powered buses. The immediate indications of a dual AC bus failure are a blank First Officer ADI and HSI display, blank ICAS displays, and an activated standby engine indicator.
AC power is distributed through the left and right main buses and the ground service bus. The right IDG normally supplies power to the right main AC bus, and the left IDG normally supplies power to the left main AC bus. The APU can provide power to both main buses when not powered by any other source. External power, when connected, can supply power to both main AC buses. Bus tie switches can isolate the right and left main buses.
The main points of AC distribution are the left AC bus and the right AC bus. Amber bus off lights on the electrical control panel illuminate if the respective bus is not powered.
Normally, the left main AC bus distributes power to the left utility bus, captain's flight instrument transfer bus, left AC transfer bus, and the standby AC bus. Power is also distributed to the left main DC bus through the transformer rectifier unit, TRU. Similar to the left main AC bus, under normal conditions, the right main AC bus distributes power to the ground service bus, right utility bus, first officer's flight instrument transfer bus, and the right AC transfer bus. Power is also distributed to the right main DC bus through its TRU.
The ground handling bus can only be powered on the ground. It is automatically powered by the APU generator or external power. With either of these two power sources available, the ground handling bus is automatically powered. The ground handling bus powers the cargo compartment lights, the cargo door electrical operating systems, and airplane refueling.
On the ground service bus can be connected to external power with a switch located on the forward cabin attendant panel. However, any time the right AC bus is powered, or the ground handling bus is unpowered, the ground service bus feed relay automatically reverts back to power from the right AC bus.
The ground service bus powers the main and APU battery chargers and miscellaneous cabin and system loads throughout the aircraft. Review. The ground handling bus is only powered on the ground. Either external or APU can power this bus, with external having priority over APU. External power merely needs to be plugged in. It does not need to be selected on.
The captain's flight instrument transfer bus is normally powered by the left main AC bus, but can be automatically powered by the right main AC bus if a failure occurs on the left main AC bus. The transfer can only occur if the left bus tie switch is set to the auto position. This switch should not be selected to isolation unless directed by non-normal procedure. The first officer's flight instrument transfer bus is normally powered by the right main AC bus, but can be automatically powered by the left main AC bus if a failure occurs on the right main AC bus. The transfer can only occur if the right bus tie switch is set to the auto position. This switch should not be selected to isolation unless directed by non-normal procedure.
You have learned that the left and right AC buses normally power the left and right AC transfer buses. The only alternate power source for the AC transfer buses is the hydraulic-driven generator, or HDG. Since these AC transfer buses power electrical systems deemed necessary for ETOPS operations, they remain powered in case of a dual main AC bus failure. If power is lost to both main AC buses, the captain's flight instruments are powered by the hydraulic-driven generator. As indicated earlier, when there is only one electrical power source available, the left and right distribution systems can be powered from one source through the two bus tie breakers. The bus tie switches must be in auto. The isolation position of each bus tie switch has an effect on other electrical components as well. Let's discuss the priority of the three generators. The following priority determines which power source is applied to an AC bus with the bus tie system operating. Number 1, respective engine-driven generator. Number 2, APU generator. Number 3, opposite engine-driven generator. External power must be manually selected. It is not in the priority system. Pushing the external power switch to on replaces APU power or engine-driven generator power with external power. For example, you will select external power to on when parking at the gate arrival after external power is plugged in and the available light has illuminated. This action disconnects any other source of power and applies external power to both sides. With external power applied to the aircraft, the respective AC bus will be powered by the engine generator upon engine start. We now show an engine starting. The associated generator automatically replaces external power only on the respective AC bus. Let's start over at the gate with external power applied to the aircraft and with a good APU. The external power will not automatically disconnect when the APU is started. With the APU running and the APU generator switch in the normal on position, you must deselect the external power switch to allow the APU generator to power the system. Back to the bus priorities. Here we show both engines running and the generators online. If an engine-driven generator fails, the opposite generator or the APU generator, if available, will automatically take over. When a generator cross-ties from one side to the other, the utility buses are shed.
The right engine-driven generator is inoperative, shedding the utility buses. The non-normal procedure instructs the flight crew to start the APU. After the APU is running, its generator automatically replaces the failed engine's generator as the power source for the right main AC bus. The utility buses come back online.